Welcome back, guys. Let's wrap up our discussion around revision in evolution. We've just looked at Lamarck's theory, we've unpacked Darwin's theory, we've had a sense of what does it mean to apply Darwin's theory in using that in different examples to explain how species have formed. In this segment, we're going to apply that to understanding how to answer a few questions. We'll also try and unpack some concepts such as punctuated equilibrium and gradualism. Let's get straight into some application-based questions. The question reads, in a population of mice, half were light in color and half were dark. So if we look at that, there's probably an equal distribution of your dark and light colored mice in a population. Okay, so we see that that's an example of that. If owls hunt in the area at night, which mice have the more favorable characteristics? So we often refer to individuals having variation. Again, we see variation amongst the mice. Some are dark colored, some are brightly colored. An owl is a bird that preys or catches its food at night. It's nocturnal. It is adapted to being able to see better at night. However, these mice also feed at night because it's probably ideal for them to access food when many of the predators are away. Having a different color of coat gives some individuals a better advantage or not necessarily an advantage. In this case, these individuals against the dark surface or at night are more likely to be seen by the owls. So we'll find that the individuals that have a darker color, in this case the darker mice, will be less likely to be seen. And you know that, guys, at night it's difficult to see things that are dark in color. And hence, if you have a bright color on, you're more visible. To the disadvantage of these mice, being brightly colored gives them a disadvantage because they're most likely to be visible or seen easily by the predator. So the answer to this question would be, guys, we'll find that the owls that are able to see at night are most likely going to target the white colored or the bright colored mice. And the ones that are less likely to survive, or more likely to survive, will be the dark colored mice. And that is essentially the concept that underpins natural selection. Why? Because they will be difficult to be seen against the dark background. And this in turn means that they will be better camouflaged at night, which in turn means that they're able to access resources. Gradually over a period of time, they're able to reproduce and produce more individuals that are better suited to that environment. Unlike the light colored mice, there will be a fewer individuals that survive. They're likely to reproduce, and if they do, they produce more offsprings having that characteristic, again an unfavorable characteristic. Hence, over a period of time, the distribution in the numbers of dark colored mice and your light colored mice would radically change. The dark colored becoming significantly more and the light colored becoming significantly less. And that is what causes what we refer to as the difference in the distribution within a species to a point that we have natural selection favoring a particular type of individual based on a characteristic they have. Let's unpack another question. If the predator was a snake that detects the body heat of its prey, which mice would probably have the more favorable variation? So now, guys, we're talking about a change in the selection pressure. So previously, in that other question, we looked at the predator bird, which was an owl, and its ability to see individuals at night was based on their color of their fur. Now we're looking at a different selection pressure. Here we have a snake that relies on being able to sense the heat from its prey. We know that if we compare individuals that are darker skinned or have a dark color, they're more likely to absorb more heat from the sun during the day. However, the light colored individuals will reflect the heat. So purely based on that, there is a likelihood that the dark colored mice would have absorbed more heat and will probably radiate more heat to their surroundings. And that in turn means that if we look at a predator that detects body heat, it's most likely going to pick up the darker colored mice. And now we see that there's a selection pressure that now changes or favors having a light colored skin, or in this case, fur. So the light colored mice are more likely to be not visible. And you'll find that, and that's because we know that, as I explained, the light colors absorb less heat than the dark colors, and hence their numbers will gradually increase over a period of time if the selection pressure of this, in this case, the select numbers increase in that particular environment. The next question, let's look at that. Tabulate two differences between the theories of Charles Darwin and Lamarck. Guys, this is a favorite question that often comes up. It is a question that often challenges you on your ability to be able to differentiate the theories that Lamarck had put forward and Darwin had put forward. So it's an important question that you must practice and make sure that you have the notes for this type of question. Let's read that. It says tabulate, and the word tabulate essentially points to putting things together in a table. Remember that a table needs to have a heading. It also needs to have clear columns that clearly differentiate between what you're comparing. I also would like to pause here and give you context to what a comparison is. Guys, it's important that comparisons need to be relative to each other. When comparing two objects, you cannot compare the size of an object to the color of an object. That is not a relative comparison. You've got to compare realistically a characteristic in relation to the other. So the classical example is you've got a big cat and you've got a brown cat. There's a big difference in that comparison. We've got to compare, as I mentioned, the characteristic relative to each other. So let's try and look at what is the answer for this question. So I've put that into a table, and we know that Lamarck spoke of members of the population are the same. However, Darwin mentioned that there was lots of variation within the population that he referred to as variation in the species. Lamarck mentioned that individuals are able to change or transform during their lifetime. Darwin, on the other hand, mentioned that transformation took a longer period of time and only through genetic means. Essentially, the changes that happen were through genetic characteristics being inherited and not through an attempt of trying to change, which is essentially a transformation process that we see. We also note that individuals choose which traits to pass on to the offsprings, and changes are directed to meet survival. And that's what Lamarck said, is that it was an intentional process, that individuals changed to suit the environment. However, Darwin mentioned that natural selection favored individuals and that there was a selection pressure causing change and individuals to become different. Right. As we wrap this segment up, there's a nice question that I'd like to get into, and it reads, the maned wolf is the closest living relative of the now extinct Falkland wolf. The maned wolf lives in a habitat of very tall grass in South America. The wolf has a reddish fur with black legs and rotating ears. The maned wolf has an exceptionally long legs, as you see in the image on the top right hand side, and believed to be an adaptation for seeing or looking over the tall grass and look out for its potential prey. So these adaptations are significant for, one, its habitat. And so these are unique to its habitat. The question that I'd like to wrap this section up with is explain the long legs of the maned wolf using the theory of evolution by natural selection. And guys, this is a typical question that you would get where you've got to explain the theory using an example. Again, it is pinned by the 4 or 5 concepts that we discussed, that individuals produce offsprings, Amongst the offsprings, we see variation. In this case, we see that there's variation in the length of the limbs. Amongst them, these have a better chance of being able to find prey or food or see predators. Having shorter legs gave individuals a disadvantage. The favorable characteristic was then passed on, and those that had short legs could not find prey and did not pass on their traits, so they died. And so we see that gradually over a period of time, the wolf with long legs could find prey, they survived easier, they produced more offsprings, gradually leading to the number of these individuals increasing. And guys, that's how you would have to use that theory of natural selection to explain the existence of species that currently have survived. We can also use the example of natural selection to explain how cheetahs have evolved. So guys, your understanding of evolution is based on the concepts. Go back, review the concepts, look at these concepts and understand that these concepts can be tested in different scenarios. You should have a list of terms that underpin your understanding. I trust that you've enjoyed the lesson and that you've appreciated the engagement that we've had. From my side, have a good day. See you soon. Cheers.